Hello everyone and welcome back to my channel. In this video, you're going to learn about propositions and truth tables. This is a very first chapter or very first lecture in your class, which has different names in different schools. It can be called Foundations of Pure Mathematics, can be called Set Theory, sometimes it's called Transitions to Advanced Mathematics. So I don't know what your school calls it, but the content is the same, so don't worry. If you have taken formal logic in your philosophy department, it will be helpful in the beginning, in the first few chapters, and then this is a math class. Okay, so in this video, you're gonna learn about what is a proposition. We're also gonna juxtapose it with what it's not, which is open sentence. We'll talk about what that is. And examples of propositions, and we're gonna see why some sentences qualify to be called propositions and some fail to be called propositions. Logical connectives such as and, or, and negation, no, look, not. Those are logical connectives and truth tables that come with logical connectives. Okay, so let's start at the beginning. Define what is a proposition. A proposition is a type of a sentence that is definitely either true or false and nothing in between. There's no ambiguity. It's a binary thing. It can either be true or false, okay? It's either spin up or down, plus or minus, switch on or off. Either this or that. Can be both, can be anything in between. So if you think about it, how many sentences that you use during the day are statements, aka propositions? Very few, because most sentences don't lend themselves to be judged whether they're true or false, right? Also, other textbooks can call it statements. Some textbooks go back and forth, proposition or statement, they call it both. And it doesn't depend on unknowns or context. So, as we just said, it can be one thing, true or false, not both. So it has a truth value. Truth value is basically the status of a proposition. It's either true or false. It's either spin up or down. It has one slot, one little box that you have to say true or false, okay? So before you judge a sentence if it's true or false, you may be given in your problem set a trick question asking you to see if that sentence is true or false. First, you need to stop and see if that sentence is a proposition. Because if it's not, you can't talk about and get into whether it's true or false. Okay, so you would stop there. But if you determine that it is, then you will think about if you can identify if it's true or not. Sometimes you are not able to identify if it's true or false, but it's still a proposition. We'll see that in a second. So this sentence right here, the square root of 49 is 7. This is a proposition. Not only its truth value is true, but even if I said the square root of 49 is 5, it would still be a proposition. In that case, its truth value would be false. But it's that type of a sentence that can either be true or false. That's all you need for a sentence to be a proposition. That's a necessary and enough requirement for a sentence to be categorized as a proposition, okay? So another sentence such as close the door behind you, we understand that's not a proposition. So it would be a mistake to say false or true or anything there. We would not do any of that. We would say not even a proposition. No. Okay, so don't be tricked in your problem sets. Let's draw a distinction here. When you're learning something new, it's very useful to see what it's not. So proposition is same as statement, and it is not same as open sentence or predicate. Okay, what I mean by that. And by the way, open sentences and predicates, that's the same thing, is coming up in few chapters. So proposition is something that has definite truth value, either it's true or false. An open sentence doesn't. It involves a variable, it's dependent on context, and then you will quantify its open sentence, and then you will talk about its truth value, and you'll see how in few videos. But let me give you an example. 5 is a prime number. This is a proposition. Not only it's true, but it's a proposition because it's either true or false. However, X is a prime number is not a proposition because it depends on the choice of X. If I set X equal to 5, then it's correct. If I set it to X equal to 6, then it's not. It's context or variable or unknown dependent. X is an unknown here. So therefore, this is not a proposition. Now, if you quantified it later, you will see that. If you gave it conditions, X is a prime number if and only if it's divisible by itself and 1. Okay, that's already like rigged. You rigged it, right? You were like, okay, X is a prime number, but I'm going to give it conditions. So that's coming up later. So create a little container for your brain for the future. Let's go over some sentences. This is a little bit of a quiz if you have a grasp of what we've talked about this far. So, and categorize the following sentences. All triangles have 3 sides. Okay, this sentence is a proposition. Even if I said all triangles have 4 sides, it would still be a proposition because it's either true or false. X squared minus 4 is 0. This is not a proposition because it depends on the choice of X. It's only true in a couple of cases, right? So it's not a proposition. 7 is greater than 10. That sentence is either true or false. Therefore, it's a proposition. Therefore, it's a statement. Its truth value is false because 7 is not greater than 10, but it's a proposition. There is life on other planets. Okay, this is a proposition, even though I don't know the answer, whether it's true or false. I know that it has one truth value. It can either be true or false. It can't be that there is life on other planets and at the same time there is no life on other planets. It's either true or false. So it can be that you can't know it, but it's still a proposition. And the final example, she's the smartest in the class. This is not a proposition for the same reason as why x squared minus 4 equals 0 was not a proposition, because it depends on the choice of she. Which she, right? So that's why it's not, there's ambiguity there, and with propositions, there's no ambiguity, no dependence on context or choice of variables. So here's a screenshot if you want to take a screenshot of this example sheet. And we're moving on to statements and logical connectives. Although logical connectives only work with statements. So once you've determined that the sentence you are working with is a statement, is a proposition, then you can glue them together, 2 propositions or more, with connectives such as and, or, and negation, which is no, not. And mathematical symbols for them are as listed here. So and is legs down, or is legs up, and then not is tilde up. Okay, and is called conjunction. Okay, so let's talk about colloquial English. Forget about math, forget about statements. If I told you I will study math and physics, both physics and math, then what does that mean? That means that for me to fulfill what I just told you, I would need to do both. I would need to study physics and I would need to study math. Both check marks I need, right? Otherwise, I have not come through on what I told you I would do. When you look at truth tables of conjunction, and it is very standard to take the first statement, in this case, it's not a statement, but I just want you to get a feel of and. When you take the first statement and denote it as P and the second as Q or am in this case. So the first statement is I'll study physics. Second statement is I'll study math, okay? And the conjunction sentence is I will study physics and I will study math. P, conjunction, am, okay? It is true once only, when I do both, when I get both check marks. That's the only time I have come through on my promise, what I said I would do. If I have studied only math, then it's the P and am, the conjunction is false. If I've studied only physics, then it's false again. And if I've studied neither, it's false. Okay, so conjunction truth tables will always look like this for any scenario, so you can screenshot it here and keep it. And is quite demanding. conjunction is quite demanding. It's very difficult to satisfy conjunction condition, okay? It's true once out of 4 cases. It's only true in 1 row, as you can see here. Okay, let's talk about an actual mathematical example of conjunction. And I gave you an example where it didn't have statements on either side of and, but in mathematics, you need to have statements on either side of and, okay? France is south of Italy and New Zealand is in Europe. Okay, this is a totally great conjunction because both of the conjuncts, the one that is on the left, France is south of Italy, is a statement, and one that is on the right, New Zealand is in Europe. That's a statement as well, and they're called individually conjuncts. France is south of Italy is conjunct number 1, and New Zealand is in Europe is conjunct number 2. And both of these are statements, they're propositions, because France is south of Italy can either be true or false, and New Zealand is in Europe is either true or false. It is either in Europe or it's not in Europe, right? So it's a statement, it's a proposition. And for you to form conjunction, you need at least 2 conjuncts. So the first conjunct is France is south of Italy. And for you to decide if the whole conjunction is true or false, you need to think about whether both conjuncts are true. That's the only time when conjunction is true. So let's see and examine that. France is south of Italy. False, right? Because it's actually north of Italy. So New Zealand is in Europe. It's false, right? So then if we have that scenario where both conjuncts are false, we're in line 4, and conjunction P and Q is false. You can actually, for conjunction, only check one of the conjuncts and be done. If one of the conjuncts is false, then you're done. Of course, if the first conjunct you checked was true, you keep going and make sure the other one is true as well for you to say that this is true, because you need both. But in a case where both are false, you can start with one is false, and be done, and know that P and Q as the entire conjunction is false. That's how demanding conjunction, same thing as and connective, is in logic. It demands that both are fulfilled. Now, or, as we just talked about it, France is south of Italy or New Zealand is in Europe. This demands that one of these are true for it to be true. It's true 3 times out of 4. It's very not demanding connective. The scenario where neither of them are true, both are false. Therefore, we're again in a 4th line, and this disjunction is false. And in the case where you have or in between, these statements are called disjuncts. Individual statements are called disjuncts. So there's the structure of it is disjunct number 1, disjunction, the symbol, and disjunct number 2. And then finally, negation. Negation is quite easy, okay? And you can say not France is south of Italy, or put not somewhere where you think makes grammatical sense. So you can say France is not south of Italy. Okay? So, and this is something that you will understand when you think about this enough. If the original statement was false, the negation of that must be true, because statements are either true or false. And if my original statement was false, then negation of that has to be true. If France is south of Italy was false, then France is not south of Italy has to be true. And it goes like that. If you start with original statement being false, the 1 tilde, 1 negation will get you to true. 2 negations will get you back to original. 3 negations will get you to true again, and so on and so forth. You can go indefinitely like that, and there will be some homework problems that will ask you to do put 3 or 4 even number or odd number of negations and see where you end up. So if you started with true, 1 negation will get you to false, right? Because statements are either true or false. And if original was false, its negation is true. Okay, so that's all that you need to know about negation.